Dear learners, welcome to another session of Java programming. We will be discussing packages in Java today. I am Anurag Bhatt, Assistant Director, Computer IT, Uttarakhand Open University, Haldwani. So today our learning objectives are fundamentals of package. What is package? We also will definitely know why do we need package, how to create a package, structure of a package, and definitely we will use a package with some example. So just to have an introduction, in Java, programmers can create several classes and interface. After creating these classes and interface, it is better if they are divided into some groups depending on their relationship. Thus, the classes and interface which handle similar or same task are put into the same directory or folder, which is also known as package. Packages act as containers for classes. A package represents a directory that contains related group of classes and interface. Now, what is a package? A package is a group of similar types of classes, interfaces, and sub-packages. Packages are also used in Java, can be categorized in two forms: built-in packages and user-defined package. We can have packages which are built-in. For example, we can have the predefined packages like java.lang, java.awt, java.javac, swing, net, and so on. There are so many kind of built-in packages we have in the latest versions of Java. Java.util, java.sql are also added. Packages enable grouping of functionality related classes. Package names are dot separated. I have also discussed that there is a nomenclature or fully qualified name of Java package. In example, we are having java.lang. So Java is a package and lang is also a package. So fully qualified name is java.lang. So under Java package there is a sub package called lang, and so on. We will discuss in later slides. Package names have a correspondence with the directory structure. It follows a directory structure like I have previously also discussed, that java.util, java.lang in the same way. Packages avoid name space collision. There can also be two classes with same name in same package. So there can be a collision. For example, if we have a package A and we are having a class B. So a class B can be in some another package, but in the same package it cannot be more than one with the same name. But two packages can have a class with the same name. So we can have two packages which have a class with same name, like I have discussed previously also. Exact name of the class is identified by its package structure. Fully qualified name, java.lang.string. In this, Java is a package, lang is also a package, and string is a class. Java.util.arrays, java.io.bufferedreader, java.util.date. Learners, one thing I would like to add, that packages start normally with a small case letter. For example, here java.lang. J of Java is small cap, small cases. L is also small in a small case, and string is a class. As it is a class, it is in a uppercase. So java.lang.string. In this, Java, lang, both are package. Java is a super package, lang is a sub package, and string is a class. In the same way, java.util.date. So date is a class, java.util, both are packages. Here, this is the hierarchy of packages and sub packages. Java is a package, then lang, util, awt. It is also these are also packages, and these are sub packages of Java package. Now in lang we have system.class, then string.class. In util we are having an ArrayList.class, map.class, both are in util, and in awt we are having button.class. So these in the leaf node of this tree all are classes. In the intermediate nodes we are having sub packages, and the top root node, that is Java package. Now why do we need packages? One can easily determine that these types are related. one knows where to find types that can provide task related functions. The names of your types won't conflict with the type names in other packages because the package creates a new namespace. One can allow types within the package to have an unrestricted access to one another, yet still restrict access for types outside the package. So, the basic concept behind this is that we are having some restrictions over access. If we want to access all the files, all the methods of a package, we use, suppose we are having some package called java.lang. So if we want to access all of the things, we will use java.lang.star. So dot star is the operator, which can be used for accessing all the things. In suppose we are having A and sub package B. So A dot B. If suppose we are importing A dot P, A dot B. So we can have all the access of B, but with some restricted accesses. How to create a package? Packages are mirrored through directory structure. We have discussed to create a package, first we have to create a directory structure that matches the package hierarchy. Advantages of Java package. Java package is used to categorize the classes and interface so that they can be easily maintained. Java package provides access protection. Java package removes naming collision. How to create a package? Package structure should match the directory structure also. To make class belongs to a particular package, include the package statement as the first statement of source file. Now creating a package. Suppose we have a file called audi.java. In this audi is a class, add.java is its extension, and we want to put this file in a package called cars. So car is a package and we want to add this audi class inside that package cars. So creating a package, the steps, first thing we have to do is to specify the keyword package with the name of the package we want to use. In our case, it is called cars. On the top of our source file, before the code that defines the real classes in the package, as shown in our audi class in the next slides, with the steps and code base of Java. So here are some steps. This suppose in first line we are having comments, we can put anything, then package name, we have to provide some name, in our case it is called cars. To define the package in Java, package keyword is used. Public class name, we have to put name of the class here, then public static void main, string args, we usually do, then declaration of the class and body of the code. Here the code ends, and we have just used public class name and we have just put the name of the class. The key feature is the keyword called package. So to define a package in Java, this keyword is always used. This is the structure of packages in Java. For example, we are having car is a Java package and it is having Audi and BMW, both are sub packages, and Audi contains these engine, gear and tire classes. So these engine, gear, tire, these all are classes under Audi sub package. And in another example, we are having speed, body and gear in the BMW sub package. So the leaf nodes in this tree all are classes of the packages. In the intermediate nodes, we are having sub packages called Audi and BMW, and in the root node, we are having car as a Java package. Defining a package in Java code base. Include a proper package statement as first line in the source file. Make a class engine belongs to package Audi. So just we are using it, package cars.od. Audi is the class name, cars is the package name. So package keyword is used to define a package here. Public class engine, we are defining its body. Then we are creating a function public engine. So system.out.println, this is class engine of package Audi. So we have just understood the concept that we are having here the class engine under the package Audi, and here is the definition of the code. Points to remember here are: one thing you must do after creating a package for the class is to create nested subdirectories to represent package hierarchy of the class. In our case, we have the cars package which requires only one directory, so we create a directory OD and put our properties of cars into it. Here are some examples of Java package. First example, we are saving this file as audi.java because audi is the name of the class. So, to start with, package cars, then public class audi, public static void main, then string args, then system.out.println, and we are just printing the message inside the package cars and class audi. So, I am elaborating this program. This is package cars. So, our package we are just creating is cars, and in this car we are defining the class audi. So, class audi is having this under the main function we are printing this package, inside this package cars and class audi. So, here is first example of package. Then second example, we are making a class called sample.java under my package. So, we are creating a package called my package. Now, saving this file, which we are writing this code, saving this file as sample.java because the name of the class is Java. So, package my package, then public class sample. So, inside this my package we are defining the class sample, public static void main like we always do, string args, then system.out.println, welcome to our first package. So, here is the second program. In this we are just elaborating the concept of package, and we have created my package as a package, and then under it a sample class we have just defined. Now, coming to the compilation of these packages and classes. Compiling a Java package, we follow the syntax as given below. javac, Java compiler, just we just use usually javac -d, then directory Java file name. For example, in this particular program which we discussed today, java -d dot sample dot java. So, I just want to explain you that the -d specifies the destination where to put the generated class file. So, to provide the destination, you can use any directory name like home. In case of Linux, we use home directory and other directories, and then in case of Windows we can use D, and then directory name is XYZ, ABC, etc. If we want to keep the package within the same directory, we use the dot operator. So, whenever there is a condition where we want to keep our package in the same directory name, so we use dot operator. Running a Java package program, we have to use fully qualified name to run the class. For example, here my package.sample. Here my package.sample is a fully qualified name. My package is the name of the package and sample is the name of the class. For our Java program example, to compile we are using javac -d.sample.java, and to run Java mypackage.sample. So, we are providing the fully qualified name mypackage.sample here. Now, as we see, the output of this program is welcome to our first package. The -d instructs the compiler where to put the class file, that is, it represents the destination. And another way, the dot operator or dot symbol represents the current folder. Now, we will cover accessing packages from another package. Now, we will be trying to find out the way in which we can access a package from another package. The methods or ways to access the package from outside the package. So, how can we perform this action? This will be performed by three steps or three ways. First way is using package.star. So, we will be using package.star in order to access one package from the other package. Second way is using package.className. We have to identify the name of the class followed by the package. So package dot class name will provide us another way for accessing package from another package. Third is using fully qualified name. We have to provide the fully qualified name of the package or class through which we can access that particular functionality. So I am elaborating here the first way, that is using package name dot star. So by using package dot star, we can access all the classes and interface of this package, but not sub packages. The thing which we have to keep it in our mind is that the sub packages are not included by this method. So suppose if we are having a and suppose we are having a package called a, and we are using or importing that package a dot star. So all the classes and functionalities present in the package will be accessed, but if there are sub packages inside it, for example a dot b dot c, so b and c, the other sub packages in this particular package a, will not be accessed by using package name dot star. So we have to keep it in our mind. The import keyword is used to make the classes and interface of another package accessible to the current package. Example of this package using package name dot star. So we are here having two classes called x and y. This is y, this is x. So we will be saving it by x.java. It is simply obvious. Package pack1. So pack1 is the package 1 which we are identifying. So the scenario is like that: pack1 is package 1, pack2 is package 2. So package pack1, we are just declaring it, then public class x, public void message. So here we are having a message in the class x, which is returning output as hello dear learners. So we are providing the command system.out.println hello dear learners. Now coming to the second scenario. Second scenario is we are having another class called y, which is under package 2. So package 2 is pack2. We are representing it by pack2. So it is user defined, you can use any name. So package pack2, then import pack1. So we are importing the pack1, means the previous package in which the class x was there and void message msg was there. Now class y, we are just defining it, public static void main string args like we usually do, then x obj. So we are here creating an object of class x. So obj x obj equals to new x. We have created an object called obj which is of type class x. Now this obj dot message, it will be creating, or rather it will be calling that message function from the class x. So how it is possible? It is possible because we are having pack2 which is importing another way of importing the pack1. Pack1 is package 1. So package 1 had class x, which in turn has message or message method. So this message method will be called by an object of class x. So now here we have just used pack1 class as well as its function in package 2. So here we are using the package name dot star in order to get access of the previous package or first package. So in one way or the other we have accessed one package simply from the other package. The output will be hey, hello dear learners. So in this we have discussed way 1. Now way 2. Way 2 is using package name dot class name. Now here let me tell you the scenario. By using package dot class name, we can access only declared classes of this package. So what we can access? We can access only declared class of this package. Now Example of package using package.name, package.class name. So here also we have two scenarios. One is class X, one is class Y. So package1, pack1 is package1. Now we are defining it. We are having public class X. So here class X is basically found under pack1. So public void message system.out.println. Hello everyone. Now the scenario which we are discussing here is we have a class X under the package pack1, that is package1, and class X is having message method. This method is printing the message hello everyone. So I think that you have understood this. Now coming to the class Y. Now package pack2, we are just defining the package 2 and I am providing import pack1.x. So here we have not in the previous method we have just been used package1.star, but here we are just providing pack1.x, means we are providing the class name package.class name. So here the specification is pack1.x. Now in pack2 we are having a class called class Y. So class Y in its definition it is having public static void main. A main function is there, string args like we usually do, x obj equals to new x. Here we have just created an object obj of class X. Now this obj will be calling the message which is defined in class X of package 1. So it is another way of using one package from another package by simply using import pack1.x or pack1.class name, whatever you want to give the name to the class. So obj.message, in this obj.message the created object is of class type X and the message itself is present in, the definition of the message is present in class X, which is itself in the package 1. So here we have just used another way to get access for one package from another package. The output is hello everyone. As we can see that hello everyone is in the class X and under the definition of message of the class X. Message is a method here. Now going to the third method, using fully qualified name. In our previous session we had discussed what a fully qualified name is. A fully qualified name is basically the hierarchical structure of a package, sub package and another classes inside it. So for example, java.lang, java.io, java.util, java.sql, etc. So we have just discussed two methods. Here is the third method. Third method is by using fully qualified name when we can access only declared classes of the package, of this package. Rather, by using fully qualified name, we are just instructing rather to the compiler that we have to go to that particular class or package. Now there is no need to import. So import keyword will not be used, there is no need, because we are providing the fully qualified name of that particular class as well as sub package. Now in this third method we must use fully qualified name every time to access the class or the interface, because there is no link which was previously provided by the keyword import. So we will be using fully qualified name every time. Whether we want to create an object, we have to use that fully qualified name to access the class or the interface. It is generally used when two packages have same class name. Example, java.util and java.sql. Packages contain date class. So one interesting scenario I would like to share with you, that java.util is a package under util is a sub package under Java package and SQL is a sub package under Java package. So these both packages, java.util as well as java.sql package, contain the date class. So in which class we are providing the functionality, we have to specify. So java.util, if we want to use that, java.util is also having date class and java.sql is also having date class. So this scenario which we have just discussed using fully qualified name, it is generally used when two packages have same class name. Now this is example of package using fully qualified name. Now the scenario is just same. We are having a class X and a class Y. The class X is in package 1. We have denoted package 1 as pack1. So you can use any name, it is user defined. So class X is having a method called message. The hierarchy, let me quickly tell you the hierarchy again. 1 is package 1, inside it we have class X, then public void message. We are having this command, this method system.out.println hello world. So X is having a message method which is providing the print message as hello world. So we have saved it by x.java. Now another is y.java. So what this class is having, this is having package pack2 and class Y. So public static void main string arg. So this is very interesting that we did not use any import keyword here, just pack2, package pack2 or package 2, and we have not imported anything. We have just defined the class Y. So public static void main string args, then pack1 dot x obj. So here in previous example we were using x obj is equal to new x. We have creating the object here using fully qualified name. So fully qualified name is nothing but pack1 dot x. So here we have defined the third way, obj dot message. So this obj fully qualified name of pack1 dot x. So pack1 dot x is a type of package 1 x. It can also be read as object of class x of package 1. So we are using the nomenclature in the reverse order. So for example, pack1 dot x obj, so it is read or understood as object obj of class x of class pack1. So pack1 dot x obj equals to new pack1 x, pack1 dot x, sorry, using fully qualified name. Then we have called object, through this object we have called message method of the class x. Now because it is having the output hello world in the class x, so we are also having the output of y class as hello world. So learning outcomes of this session. Learning outcomes are, let me quickly revise you all the concepts we have discussed today. Basic understanding about structure and functioning of a package. So we have just understood about how the package functions, what is the structure of a package, and what are the hierarchical structures, the tree diagram of package, then sub packages, then leaf nodes called as classes. So next we have understood the concepts of fully qualified names of classes and packages, knowledge to create, compile and run a package. We, through elaborative examples of programs, simple short programs, we have gained knowledge to create, compile and run a package. And last but not the least is use and implementation of packages. We have used and implemented packages in certain scenarios in order to view the usage of one class into the other class, and another class can be accessed by using three methods. We have just discussed the three methods of the using one package from the another package. So, thank you so much, learners. I hope that this session will be very beneficial for you and you have gained key concepts regarding packages. So, here are the differences and thank you so much.